Hydrogen. Hydrogen is the first element of the periodic table. Its atomic number is 1. It is the lightest element present on the Earth. Like carbon, it is also a non-metal, but in the activity series, it is grouped with metals. Its symbol is H, but it exists only as a molecule, H2. It is the first element of the periodic table with only one electron, one proton, and neutron. The molecular formula of hydrogen is H2. It is called hydrogen due to its tendency to produce water on burning in an atmosphere of oxygen. Hydrogen was named by French chemist Antoine Lavoisier, but discovered by Henry Cavendish. Henry Cavendish. The English scientist Henry Cavendish, 1731 to 1810, found a gas he called inflammable air, but he did not identify it as the element hydrogen. He investigated the properties of the gas and showed that water is formed when it is burned in air. This proved that water is not, as had been thought, a separate element. Later, the gas was called hydrogen by Lavoisier in 1783. Occurrence of hydrogen. Hydrogen is the most abundant element in the universe. The outer atmosphere of the Sun and the stars consist largely of hydrogen. On the Earth, free hydrogen occurs in very small quantities. In combined form, this element is present everywhere. It is a vital constituent of carbohydrates, fats, and proteins, which form the body of plants and animals. It is also present in large amounts in mineral products. Water is an important compound made of hydrogen and oxygen. Methods of preparation. Since hydrogen is not available in its free state, it has to be prepared from its compounds industrially or in the laboratory as per the requirement. Displacement from water by metals. Metals like potassium, sodium, and calcium react with cold water, releasing hydrogen and forming corresponding metallic hydroxide. And potassium is explosive in nature. Hence, they are not used in preparing hydrogen. Ca plus twice H2O gives CaOH whole twice plus H2. Twice Na plus twice H2O gives twice NaOH plus H2. Metals like zinc and iron react slowly or at moderate rate with water. They form their respective metallic oxides, and hydrogen evolved can easily be collected. Zn plus H2O gives ZnO plus H2. Thrice Fe plus 4H2O gives Fe3O4 plus 4H2. Displacement from dilute acids by metals. Active metals displace hydrogen from dilute acids, forming their respective salts and evolving hydrogen gas. Mg plus twice HCl gives MgCl2 plus H2. Zn plus H2SO4 gives ZnSO4 plus H2. Lead is not used to prepare hydrogen, although it is an active element. This is because on reaction with dilute HCl, it forms insoluble lead chloride, which covers lead and stops further reaction. Reaction stops because contact between lead and acid breaks. Electrolysis of water. Hydrogen is evolved when electric current is passed through water. A few drops of dilute sulfuric acid are added to water to make it a better conductor of electricity. Twice H2O gives twice H2 plus O2. Laboratory preparation of hydrogen. In lab, hydrogen gas is prepared by treating granulated zinc with dilute sulfuric acid. Experiment. Take few pieces of granulated zinc in a conical flask. Close the mouth of the flask with a 2-holed airtight stopper. Through one hole, pass a thistle funnel, and through the other hole, a delivery tube whose other end is dipped in a trough of water. Place a beehive shelf over the other end of the delivery tube. Pour dilute sulfuric acid down the thistle funnel until it covers the zinc pieces. A brisk chemical reaction takes place with the evolution of hydrogen gas, which bubbles through water. Allow some gas to escape because it is mixed with air inside the flask. This method of collecting hydrogen gas is by downward displacement of water. Invert the gas jar completely filled with water over the beehive shelf. Hydrogen gas will displace water and collect in the gas jar. Zn plus H2SO4 gives ZnSO4 plus H2. Precaution: no flame must be brought near the apparatus as hydrogen is an inflammable gas. Test for hydrogen. Bring a burning splinter near the mouth of gas jar. It burns with a popping sound, confirming that the gas jar contains hydrogen gas. Bosch's process. Bosch's process is employed to produce pure H2 for industrial use. It involves passing water in the form of steam over red-hot coke. The reaction forms carbon monoxide and hydrogen, water gas. C. Coke plus H2O, steam. Heated at 1000 degrees Celsius gives CO plus H2, water gas. This mixture of gases is further reacted with steam in the presence of iron chromate as catalyst. It is done to increase H2 production. Here, carbon monoxide gets oxidized to carbon dioxide. CO plus H2 plus H2O, steam, gives CO2 plus twice H2 plus heat, iron chromate. Hydrogen is purified by passing CO2 and H2 through cold water or caustic potash solution. It absorbs CO2, leaving behind pure H2. Physical properties of hydrogen. It is colorless, tasteless, and odorless gas. It liquefies at a low temperature of -252 degrees Celsius. It is neutral to litmus, which means that it is neither acidic nor basic. It is lighter than air. Activity. To show that hydrogen is lighter than air, take a test tube containing air and place it over a test tube containing hydrogen gas. Ensure that the two test tubes are placed mouth to mouth as shown in the figure. After a few seconds, test the upper test tube with a lighted splinter. What do you observe? you will hear a pop sound in the upper test tube. It shows that hydrogen has moved from the lower test tube into the upper one. So, it can be concluded that hydrogen is lighter than air. It is insoluble in water. It is highly inflammable gas and burns with a pop sound. Activity: to show that hydrogen burns but does not support combustion. Hold a test tube filled with hydrogen with its mouth facing downwards as shown in the figure. Place a lighted candle inside the test tube. What do you observe? You will find that candle gets extinguished, but the gas burns with a pop sound. So, we can conclude that hydrogen is combustible but does not support combustion. Chemical properties of hydrogen. Indicator test. It is neither acidic nor basic in nature because litmus paper shows no color change with hydrogen gas. It is neutral. Action with metals. Certain reactive metals such as sodium and calcium react with hydrogen to form respective metal hydrides. Twice Na plus H2 gives twice NaH. Ca plus H2 gives CaH2. In these reactions, hydrogen gas behaves as electronegative element, whereas in all other reactions, it behaves as electropositive element. It shows the dual nature of hydrogen. Action with nonmetals. Action with oxygen. Hydrogen burns in air with a pale blue flame. Due to presence of moisture in the air, the mixture of hydrogen and oxygen explodes, which we hear as a pop sound. In pure oxygen, it burns silently, forming water. Twice H2 plus O2 gives twice H2O. Hydrogen forms numerous compounds with carbon. They are called hydrocarbons and classified as alkanes, alkenes, and alkynes. Action with chlorine. Hydrogen has a strong affinity for chlorine. It combines with chlorine in presence of light. Hydrogen reacts with chlorine in diffused sunlight, forming hydrogen chloride. Moisture acts as a catalyst in the process. In direct sunlight, the reaction is explosive. No reaction occurs in dark. H2 plus Cl2 gives twice HCl. Diffused sunlight, moisture. Action with nitrogen. Nitrogen is not a very reactive element. It reacts with hydrogen only under certain conditions, forming ammonia. The equation for the reaction is as given here. N2 plus thrice H2 gives twice NH3. Heat. 200 to 900 atmospheric pressure. 450 to 500 degrees Celsius temperature. Fe plus Mo. The industrial name of this process is Haber's process. In this process, iron acts as a catalyst while molybdenum acts as a promoter, which increases the efficiency of the catalyst iron. Mo itself does not act as a catalyst. Action with sulfur. When hydrogen is passed through molten sulfur, it forms hydrogen sulfide gas. Hydrogen sulfide has the odor of rotten eggs. H2 plus S gives H2S. Fact: hydrogen is a good fuel for rockets and welding. It burns in air to produce large amount of energy and pure water, which does not cause pollution. Hydrogen is being tested as an alternative fuel for cars. The problem with hydrogen as a fuel is that it is difficult to store. Redox reactions. Oxidation is the process of addition of oxygen or the removal of hydrogen from a substance. The substance which gives oxygen for oxidation or removes hydrogen is known as the oxidizing agent. Reduction is the process of addition of hydrogen or the removal of oxygen from a substance. The substance which gives hydrogen for reduction is known as the reducing agent. Example 1. When copper oxide reacts with hydrogen, copper oxide is reduced to copper and hydrogen is oxidized to water. CuO plus H2 gives Cu plus H2O. Reduction, oxidation. It shows that oxidation and reduction occur together. Therefore, it is called a redox reaction. Example 2. When lead oxide, PbO, reacts with hydrogen, it is reduced to lead and hydrogen is oxidized to water. PbO plus H2, Pb plus H2O. Reduction, oxidation. Do you know? Hydrogen makes the sun shine. A huge amount of energy is given out when the nuclei of atoms of hydrogen join up or fuse together in the sun's hot interior. This process is called nuclear fusion. Fusion is also used in the destructive hydrogen bomb. Uses of hydrogen. Hydrogen is used in the manufacturing of ammonia gas, NH3, by Haber's process. Ammonia is used to produce fertilizers and nitric acid. It is also used in the manufacturing of hydrochloric acid and methanol. Earlier, hydrogen was used in filling air balloons for meteorological work, weather forecasting. However, due to inflammable nature of the gas, it has been replaced by helium. Hydrogen is used in the preparation of vanaspati ghee from vegetable oils. This process is called catalytic hydrogenation of oils because it takes place in the presence of finely divided nickel acting as a catalyst. Hydrogen and oxygen, when burnt together, give a flame known as oxyhydrogen flame. It has a high temperature and is used for cutting and welding metals. It can be used as future fuel for automobiles as it is pollution-free. It can also be used for generating electricity by fusion reaction. Liquid hydrogen is used as a fuel in rockets.